Direct variations are sometimes called proportional relationships or linear proportional relationships, but they represent many real-world situations. We can represent them in a story, a table, an equation, or a graph. If you go to the movie and each ticket costs $9, you could make a table, a graph, or an equation to match your story. For the table, you would want the number of tickets compared to the dollars you spend. One ticket would be $9, 2 tickets, $18, 3 tickets would be $27, 4 tickets would be $36, and so on. To make your graph, you would want the number of tickets on the bottom, on the x-axis, because that's your input, and you would like the dollars on your y-axis. 1 ticket, 2 tickets, 3 tickets. You might label it $10, $20, $30, going up by tens. You would want to plot each one of your points, 1, 9, 2, 18. 3 tickets would be 27. If you bought 0 tickets, you would have $0. Your equation here would be y equals 9x, because for every ticket, you multiply by 9 to get your y value, the number of dollars you will spend. To see if we have a direct variation in a table, we want to compare our output to our input. So we want to compare our y over x values. 8 compared to 1, that would be like $8 for 1 ticket. And then we look at our next set of points, 4 compared to 2. Those are not equal ratios. So we do not have a constant of variation, so we will not be able to find our equation, but we can graph those. So each one of these will be a point on our grid, 1, 8, 2, 4, 4, 2, and 8, 1. And we can easily graph those. 1, 8 is here, 2, 4, is right here, 4, 2, and 8, 1. Those are not linear because they do not make a straight line. Linear means they make a straight line. Use your y over x values to see if you have a direct variation. Do each one of your sets of points. 41 compared to 5, 50 compared to 10, 68 compared to 20, 86 compared to 30. And you can take any of those that seems easy to use, and you can see right away that these are not equal. Or you could even see that these are not equal. 10 going to 20 doubles, but 50 going to 68 does not double. So no, we do not have a direct variation. On this one, we have compare our y over x values, and we have 1 compared to 50. We have 2 compared to 100, which is also an equal ratio. We have 10 compared to 500, and we have 20 over 1,000. Those all reduce to the same fraction or same ratio, which is 1 over 50. We call this our k value, our constant of variation, or our constant of proportionality. That gives us our equation y equals 1/50th of x. We could also say y equals x over 50.